we try to answer. And I also hope you are now getting the how to say the things behind A/B testing versus hypothesis testing. Yeah, I hope your general understanding is now clear. So I don't want to share to present something I want more likely to talk. Normally I should be with Abla. I don't know if Abla, are you here? Sebastian, is Abla here? No.
I don't think.
Yeah, no, I think I can see her. Yeah,
Okay,
Abla,
yes,
are you
I
here?
see it.
Can you? But she's muted.
No, she's not muted though. She
Yeah.
isn't.
Hello,
Mm-hmm.
Jim, please can you go over there and
Yeah,
provide
Abla,
this?
how are you? She's there. Okay, so yeah, I saw some question. Emmanuel, I didn't see any click for rate analysis where they are shown binomial distribution. Yeah, rate analysis is beta distribution. It's not binomial distribution. For rate analysis, is beta distribution. Yeah, it's beta distribution. Okay, so yeah, normally I should be with Abla. We just want to make a short session, like yeah, about A/B testing versus hypothesis testing. Did you get the thing? So A/B testing, is that's what I started since yesterday talking about. Give me some time. I'm checking something. Yeah. Okay. Yeah. So I think I want, for example, let's say I want to give you an example. So let's say for this one, I want to make it very simple. So let's say, for example, we know that the let's say we know that the
Please,
average.
Jan.
Yeah. Can you hear me?
Uh, Abla is trying to ask if we can hear her. So I don't know if she wants to say something.
Ah, okay.
Abla, can you just try to talk? We'll see if we can hear you.
Yeah. Yeah. I think she left. I think
I think Jan, you can continue.
Yeah.
Yeah.
Okay. Yeah. Okay, so I think I will just take this example, a small example, and I want you to think about how can we actually design the A/B testing in this context. So I think I will. Okay, let me write it down. Uh, okay. Yeah. So let's say we know that the average order size is, so like I didn't give the things about the, like, give me some time. Give me some time.
Okay, please can I make a comment about the p-value and more like a question too?
Yeah, I think let's
Hello.
talk first about the the hypothesis testing and flow. Then you can answer you can just ask your question. But if you want, you can ask your question
All right.
in the chat box, and then we come on that at the right time. Yeah. So what I want to say is yeah, let's take the marketing funnel for okay. So let's say, for example, yeah, in this case, we want to take a marketing funnel for acquisition, for example, and let's say the we know that the average order size of the funnel is actually about $60 on our website. Yeah, so like from that we want to improve the order, we want to improve the sales. Yeah, and asking if you can think about.
Hello.
Yeah, hello
Hello.
Abla. Yeah, we are now
Yeah.
able
Yeah.
to hear from you.
Okay.
Yeah, so I hope you can also hear from us. Like, okay.
Yes. So should I start sharing my screen?
Mm-hmm. Yeah, we hear, but I think it's okay now. So I was just like giving them a case, a short example, like to focus on that one to talk about the hypothesis testing. Yeah. So, but Abla, yeah, is like about making a presentation now. So I think you can follow and then we discuss about the case. Yeah. So Abla,
Can
I
you see
think,
my screen?
yeah. So we do see. So you can just go.
Okay. Hello everyone. So I'll be speaking to you about A/B testing and the general hypothesis testing. So what I will do is that I'll just talk about when we usually conduct a hypothesis testing. Usually when we have a data set on hand and then we like some information about maybe the distribution or some other feature from the data, then we have some belief that we can actually talk about, and then we need to verify this kind of belief and by conducting an hypothesis testing. One typical example where I would say we need to have we need to conduct hypothesis testing will be, for example, when we toss a coin a certain number of time and then we realize that we have more head than tails, then a first impression will tell us that the probability of a head to turn up will be p, that is will be different from a half, which means that we believe that the coin is not fair. So this is just a belief, so there is need to have to test it, and then and by thinking that way we need to conduct a hypothesis test. So what do we do when we say we want to conduct a hypothesis test? We first set a null hypothesis, which is what we believe should be the case, and then we have the alternative hypothesis as well. So the conclusion we have two types of conclusion that we usually make. We either reject the null hypothesis or reject it, assuming that the null hypothesis is true. So if we reject the null hypothesis, when actually it is true, we are making a type 1 error. Then when we have made a false null hypothesis and we accept the null hypothesis, then we are making a type 2 error. For hypothesis testing, most of the time we focus on the type 1 error, which we often call the significance level. Then this is usually used in so many areas, maybe medicine, business, and other science subjects. So in business, there is a variant of hypothesis testing that we call A/B testing. It uses concept methodologies of hypothesis testing, the general one, but in this scenario, the data set, we know beforehand how the data set is constructed. But for a general hypothesis testing, we don't know for sure how the data was collected, how it was obtained. So to be able to conduct A/B testing, we know that the data has been collected in a certain way. Okay, let's give you the example of tossing the coin still. So okay, we want to compare, we are interested in knowing if a coin has a chance to give us more head than tails. So we are interested in a dollar coin. Okay, we have two variants of a dollar coin. So I want to know which one will give me more tails if I want to do an experiment and I want to toss it so many times. Which one will give me more head between the two of them? They are just two variants of the same dollar, of the dollar. One is called US dollar and the other one is called Canadian one. So one way of having that data will be, okay, we select one of the two coins randomly and then uniformly, which means I select dollar coin with probability half, or the US one, the US one half probability, or the Canadian one with half probability. I hope you can see my screen. Can you still see my screen?
Yeah, we can see your screen, like the first page, A/B testing versus general statistical hypothesis.
Okay, cool. Yeah. All right. Then, oh, sorry. Yes. Then once I select one of two, US dollar or Canadian dollar, and then once I select one of them, I toss it. I either obtain a head or a tail. So whichever outcome I obtain, I try to collect them, and I collect them from a data set. So in the table that we have in my slide, we have for the US dollar, the first time I have been able to select it, and I toss it, I obtain a head. 1 means head and 0 means a tail. So the first time I selected it, I obtained a head. The second time I selected it, still with probability, I obtained a tail. The third time I obtained a tail. The fourth time I selected a head. The fifth time it was a head still. For the Canadian one, the first time I obtained a head. The second time I obtained a head. The third time was a tail. This fourth time was a tail, and then the fifth time was a tail, and so on. And when we do this and n time for n times, which means that for each of the coin we're able to have n outcome, and then for US dollar one I have n outcome, and then for the Canadian one I have n outcome. So I want to know which of the $2 will give me more chances of having a head. So the hypothesis testing is the one that is most often used in businesses to conduct such an experiment, such a test. And then so the two samples are compared, and to check whether the US dollar that give us more head, or is the Canadian one that give us more head. So overall, A/B testing, when I say A/B testing, A stands for a variant of a typical variable that I'm interested in. A is the one variant and B is the other one. most of the times, we know for sure the performance of one. Performance here in my example is the number of head that it can give me, the proportion of head that I can obtain from it. I want a higher number of head from it. This is my measure of performance. So so if I have I know already, I have an idea about that one. The A is now the control variant of the variable I'm interested in. And then the B will be the in case of the B will be the one I'm comparing to it, to the first variable, to the first variant, sorry. Yes, so in A/B testing, the most important, the first thing to know is the metric we want to use to compare the variant of the outcome we are interested of the variable that we are interested in. So if we want to compare general hypothesis testing and A/B testing, the difference will come from the fact that, from our opinion, general hypothesis testing, we don't know for sure how the data has been collected. We have a data on hand, we try to analyze it. Okay, we have some idea, we have some guess, we have some intuition, and then we want to say, okay, is it okay if I assume this? And then if I want to check that, I conduct a hypothesis testing. On the other hand, for the A/B testing one, I'm interested in analyzing in certain performance. Okay, I want to for the case of my coin, I want to know which one performs better than the other one. So I collect data. I have a data on hand that I can collect, or if I know how the data has been collected, then and then if it is the way in which that, okay, I have two variants, I randomly select one of them a certain number of time, randomly, uniformly, a certain number of time. I collect that data and I compare the two. Then compare two samples comes back to conducting a general hypothesis testing. So it is actually, you come back to the general concept of general hypothesis testing when you are conducting an A/B test. That's all I wanted to say for today. So if you have any question.
Okay, but I think you okay. It's okay. Okay, so I think they were saying that they don't have, they didn't see the presentation, but I think it's a technical issue. What I will do is to share this with them in the today folder. So guys, don't worry, you will get it in the today folder, and yeah. So I think Abla will share this with you.
My screen was not showing at all.
Yeah. What? Come again, please.
Oh, were you not able to see my screen?
Oh, I can see it.
You can see it.
Yes, I can see it.
Okay.
Yeah. Okay. So, okay. Please, can you give a? Okay. So I think you will get also the the screen, the meeting recorded, and you will be able to hear, I hope. So I want, like, maybe if I want to, let's say I was talking about an experiment, like to complete, just to say a few things about what Abla just gave as presentation. So let's think about another experiment, like, yeah, like here we want, for example, let's take a marketing funnel for acquisition. Yeah, and then let's say we know the average order size in our website. So we have a website, so for which we are actually selling our product. Yeah, and then we know the average order size, which is actually $60. Yeah, and then we may want to test a new promotion. Yeah, so in unison base, like design to see if it's increase the sales. So the objective here is to increase like the sales, the volume of the sales, and so that we want to test the to do that we want to test a new promotion. Yeah, and I want you to think like can you imagine an A/B testing scenario, like, yeah, so how can you actually organize that? So you have a product you use to sell the product. Let's say last year, for example, yeah, you know the historical average orders of the product is no, and is fixed at $60, and then we want to improve that. We want to improve the volume of the sales, like, yeah, and we want to do that. We need to adopt a new strategy. So we want to test a promotion this time, and so how can we actually design, like, adopt A/B testing to actually check if our promotion will actually help us increasing the volume of this the sales. Yeah. So
Okay,
if
sorry,
I
can
think,
you repeat your question again?
yeah, the question is actually how can we actually think about imagine about A/B testing
Okay.
experiment. Yeah, to actually face
Yes.
that. We want to improve the volume of the cells. We want to improve the volume
Okay.
of the cells. So like this is for the learners. So if any of them have some feeling, just try, and we can discuss quickly before ending this session. So there is a question. I have a question for Abla. How do you determine the appropriate sample size for your A/B testing? Oh yeah. Does it mean that A/B testing experiment is help to surface? Yeah, Abla, did you see the chatting box? Like
A minute.
yeah, Patrick question about so how did you determine the appropriate sample size for, so this question is actually what Yabi was asking also yesterday, like, yeah, to do A/B testing, yeah, you need to optimize, you need to determine the sample size of your, yeah, your sample, your population. So like, yeah, the data you will be collected, you will collect them from some people. So you need actually to optimize in terms of sample size. Like yesterday, I remember we just said that if we want to it's depend on the volume of the impact we want to have. So if we want to have huge, if we are looking for a huge impact, yeah, then the sample size could just be small. And if you are looking for a small impact, then the sample size should be actually big. So like some optimization. So he's asking the question. I don't know if you have something to say. If you can just say something, and then we continue. Yeah.
Okay. The size of the sample is determined by looking at the type 1 error and type 2 errors. Um, the type 2 error has to be high enough, and then the type 1 error has to be low enough. Yes. So by
Okay.
varying the sample size, you the appropriate one will have a higher
So like
type 2 error, and then for
yeah.
a low type 1 error.
Okay, like your error actually have some formula and then you want to optimize the error, like the minimization for a minimization of the error. You want actually to get the sum. Okay, okay, I get it. He has another question, like also another question in calculating my p-value. Yeah, I didn't ask well. Let me speak. Okay, Patrick, I think you can speak.
Okay, also another question. In calculating my p-value, can I approach it this way? Find the probability of fitting my test
Hello?
statistics.
Yeah, hello,
Yes.
Patrick.
Hello.
Yeah.
Okay, so
Yes.
I think I don't know how to articulate it well, but I think while talking I can say it very better. So this is the idea.
Alright.
So let's say I'm trying to perform. Okay, let me just bring it down to a two sample t test. Let's say I'm trying to check the difference in mean of two population.
Okay.
And let's say I'm taking it as an approach of A/B testing. I'm trying to check the difference in mean of two population. Let's say I'm trying to say when my H naught is there's no difference in the mean of the two population, and then my alternative is there's a difference in the mean. So now let's say I'm starting from my alternative hypothesis to prove that there is a difference in the mean. Can I do something like, okay, I'll find out I'll get the difference in the mean of the two population, but I'll do it in such a way that I'll compute let's say up to like 10,000 samples. I don't know if you get what I'm
Okay.
trying to say. Let's say I compute like 10,000 sample of that particular
Yeah.
statistics. Then I say, okay, the initial now when I'm computing the sample, I'm actually doing random sampling. When I'm
Alright.
computing the statistics, yeah, I'm doing random sampling and I'm
Yeah.
replacing. So I'm definitely going to get different mean values at different points in time. So my question is, using that approach, can I use that approach to find my p-value such that after I computed 10,000, let's say I computed 10,000 means from 10,000 random samples, then I can say something like, what is the probability of me getting this particular statistics? Let's say that the difference in mean it's about 1.0, and I say what's the probability of me getting 1.0 among these 10,000 samples? Can I use that approach to get my p-value?
Which approach? The one you just described.
Yes, definitely the one what I just described.
Like you are performing the experiment a lot of time, and
Yes,
yeah, like you
using
sample,
using different yes using different samples. Thank you.
yeah, using different, like you are sample, you are making the sample a lot of time, and then you want to each time compare if the mean of this population is greater than this mean, and then you want to use like yeah, I get your feeling. Yeah, I get your feeling. And the general so is it this one, is it technical, like normally for the p-value they are following some assumption. I don't know if in this specific case the assumption are meted in your case description, but what you are saying, whatever I think, I can feel some sense behind, but normally the classical approach of getting the p-value is explained like, yeah,
Okay.
if you check, yeah, like okay, Mustafa, do you want to say something?
Yeah, I don't know if I get very well, Patrick.
Yeah.
Uh,
Yeah, I'm with you, please.
okay, so for me, okay, maybe if you can mute your mic, that there is some kind of noise.
I'm sorry. Sorry about that.
Okay, okay, can you hear me? All right.
Yeah, we do
Okay,
we do
Patrick,
yeah.
I don't know if I get you very well, but it's like you are trying to say like you are performing like an experiment like many times by doing sampling, maybe by changing the sample size, and then by like doing some hypothesis testing and trying to see the p-value. Okay, what I just understand is that the p-value depends on the tests that you are using. You know that in hypothesis testing, there are so many kind of tests. Like there is t-test, there is z-test, there is chi-square test, something like that. And in the our, I think the first week or second week, like the training week, we covered hypothesis testing, and there was an example where we took a small sample size and we realized that we have to accept the null hypothesis based on the p-value. And the same example, I increased the sample size and we realized that now this time we have to reject the null hypothesis based on the p-value, because now the p-value is very, very small. That means if like the sample size is small, there is a specific maybe kind of test that you are supposed to use. And if the sample size is bigger, there is another test. For example, the p-value is calculated based on the test you are using, the z-test or the t-test. So if the sample size is small, basically, like most of the time, we advise to use, for example, t-test. And in this case, the p-value is calculated based on the t-test. And if the sample size is bigger, and then you are still using the t-test, you realize that something will not be like something will happen, like you will not get your desired results because the sample is now bigger and you did not use the test you were supposed to use. So for me, basically the t-test depends on the size of your sample as well on the kind of tests you are using when performing hypothesis testing. I don't know if I'm talking the same line with you, but this is just my understanding from what you just said. Maybe you can explain better if I did not like answer your question, or maybe if I'm not in the same line with you.
Yeah, Patrick, can this help? Was
Can
this
I add
helpful?
something?
Okay, Abla want to add something. Yeah, go.
Yes. So, what I would like to add is, if you know your test statistics, and then you know the value that the test statistic has when given your data, then the p-value is easily computed. If you know using the software, of course.
Yeah.
Yeah. The distribution of your test statistics and then the value that the test statistic has given your data help you find your p-value.
Exactly.
Then you can compare it with your significance level and decide whether you reject your null hypothesis or not.
Yeah. Okay, so I hope this helped also Patrick. And if not, and if you have also some things to share, yeah, do not hesitate in Slack, and I think we can continue there. And okay, so do I need both? Okay, Abla, there is a question for you.
Okay.
Do I need both confidence interval and p-value to make a decision, or one is enough? So this is from Ayebila in the chatting box. Like you can.
Okay, can I just add something?
Okay.
Okay, Mustafa. Yeah.
Okay, most of the time when you want to use the confidence interval, in this case, you have calculated your t-test and you have a value for your t-test. In this case, you can try to check if that value falls in the confidence interval. Otherwise, if you want to use p-value, you can maybe forget about the confidence interval and the t-test. You can just focus on the p-value. And if the p-value is greater than the significant level, you can decide. Or if it's less, you can decide. So it's like a matter of like you to choose which one. And most of the time, if the p-value is greater than the confidence level, of course, the t-test will be in your confidence interval, and vice versa. So I think in both ways, you can use like them to take a decision, from my understanding.
Yeah, exactly. Abla, is it good? You want to add something, or it's okay? Okay. So I think confidence interval and p-value, yeah, you can use only one is enough to take actually the decision. The second one will just come in support. Yeah, so actually, yeah, p-value or confidence interval, you can use whatever you want to take your decision, and the second one is just to support the first one. Emmanuel was asking, so what is the distribution of our sample here? How do we identify the distribution? Yeah, so there are a lot of distribution, and the distribution which fit the best your sample, yeah, should be identified. But how to identify that? Yeah, normally if you have just looking at the experiment, we can, like, if you want to, we are like doing an experiment which derive a variable like uh, we by looking at the experiment we can just have an idea about the process behind, or by using also the chi-square adjustment test, we can also detect which distribution fit the best, which process fits the best to the data. So if we are doing like yes or no or true or false experiment, then we know that the process behind it should normally be binomial. So we have a prior idea about the process, but if we want, we can just adjust the chi-square test to test which distribution will just yeah, we can use the chi-square test for that. So that's what someone was also yeah, Emmanuel, yeah, chi-square test, exactly. So you can use the chi-square test basically if you don't know, if you don't have any idea of the distribution of the process behind your data, then you can use the chi-square test to check about it. If you have, that's good. But if you don't have, you can use it. Yeah. Okay. So yeah, Patrick, you have a last question. I think you can ask quickly. Okay.
Yes.
Just go.
Okay, so let's say I'm performing an A/B test. Let's say I have two different web pages, and then can you hear me,
Yeah,
please?
we do.
Yes, we can hear you.
Okay, let's say I'm performing an A/B test. I have two different web pages, and then I want to, and the metric of my test is conversion. I want to see if the old web page leads to better conversion than the new web page. Then let's say my customer or my audience, I divided them into two groups: the control group and then the experiment. And then for the control group, I just show them the old web page. Then for the experiment group, I just show them the new web page. So let's say in performing my hypothesis test, and I want to determine the p-value, and let's say I don't have as much data as possible, then but because I want my statistical power to, because from one of the things I've learned from the materials is that the higher the sample size you have, the higher the statistical power you have. So I want to have a higher statistical power to come up with a p-value that I can use to compare with my alpha to make a decision. So what I'm saying is this: can I say, okay, let me generate or let me simulate from this available data I have now, can I simulate a larger number of data from my control group and my experiment group, such that I can say, okay, between my control group, I know a function in NumPy that can do such a thing is np.random.choice.
Yeah,
So I can
yeah.
say that, okay, within my control group, can I simulate data of people who will lead to conversion and people who would not lead to conversion? So I can represent conversion as 1, I can represent no conversion as 0. So I can say, okay, what is the probability of people who lead to conversion, probability of people not leading to conversion, and I will use the size. So I simulate data for the control group. I apply the same method to the experiment group. Now I cannot find the mean of these two populations. Now, bear in mind that they are simulated populations, or let me just say simulated samples from the previous sample, which in this case now is a population. So when I find the difference in mean, I can say, okay, let's say when I find the difference in mean, discover that the difference in mean is, let's say 5, let's say 0.5, that is 50. Then in order to be sure that these simulated populations, in order to get more confidence in these simulated populations, can I do an iteration whereby I say that, okay, in 10,000 times, more like I'm rolling a dice, and I say in 10,000 rows, what is the probability that I will get an head or tail? Now, in this case, I can say that, can I say something like in 10,000 times of simulating this particular set of population and getting the difference in their mean? Can I say, we need 10,000 times, what is the probability of me getting the initial test statistic within these 10,000 ranges of mean that I get from simulating the two sampled populations 10,000 times? I don't know if I'm clear.
Yeah, but I think the world things behind is like your sample size is not enough, and then you want to
Yes.
look at your own population you want to adjust to know the distribution which fit them to the best, and then from this distribution sample more data. Yeah, and
Yes.
but the limitation here is like do you have the metric you want to compare? Like it's not that. So the
I
metric you
didn't get
want,
that. Okay.
yeah. So like, okay, I think your methodology is clear, but you know, any methodology have some limitation. You can do that and say, yeah. So I think like doing that will just help me like for one step forward, but some limitation are like related to the bias things, like example, yeah, you are using simulation instead of real data, and so like that, so you can just, I think it's good, but think about there will also be some bias behind, but yeah, I think it's if you can get less bias than the first method, like you don't have enough sample size to have a statistical power. Yes, I think I'm okay with that. If your methodology is clear,
Oh,
is clear, yeah.
Okay,
But yeah,
can I just
Mustafa,
add something?
yeah, you can.
yes.
Okay,
Thank you.
Patrick. So I get what you said. Like maybe in case that you are suffering from like having small sample size. For
Yeah.
me, like what you just described could be possible. Uh, Please, can you just unmute? You can mute. Okay. For me, what you just described is could be possible, but also okay if you have like large sample data, maybe your statistical power will be more like powerful. We are okay with that. But for me, in case you have very sample size data, you can just try to fix the threshold of your statistical power. For example, you don't have like to expect like for your statistical power to be very 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 powerful, but you can try to fix a threshold based on the sample size you have. You can just say like, if my statistical power is now this, so, okay, I can take this decision, and this decision is not the same as when you have large sample data. For me, it depends. Like if you have small data, just try to like play around on the like threshold of like the statistical power. It depends. Let me just give you an example. For example, when conducting like statistical hypothesis testing, you may realize that, for example, this is your level of significance, like 0.5. Okay, someone else might come and say, okay, my level of significance is 0. Maybe 4, maybe, and he has a reason why he has that kind of threshold. Maybe he doesn't have the same data as you, or the same sample, like his data is smaller than you. So it depends. If you have really small sample data, for me, either you maybe try to simulate by increasing the data, or you just leave it like that, but maybe you try to play around on the threshold of your statistical power. So I don't know if also this could maybe help or not.
Exactly. I think it's helpful. Yeah. Okay. So yeah. Okay. He said my network went off. Okay. No problem. Yes. So exactly. So thank you, everyone. So yeah. Okay. So if you have any other question, continue asking in the Slack channel. So Mustafa is there, Abla is there, Yusman also is there. So Sebastian also is there, and I'm there. So I think exactly. So you can okay. Yeah, you can use the approach for your task. And also remember that I don't know if so in general hypothesis testing, when we have a sample size problem, we just use a non-parametric test. Check about that one also to see. Yeah. If you use the approach in your task, you can just provide comment. Why did you use that? And if it's clear, I think it passed. Yeah. Okay, so I think this ended this session. We will continue in Slack. Yeah, thank you so much. And yeah, I'm leaving. I will stop the recording and yeah.